Okay, in this video lesson we're going to be looking at the relationships between sides and angles in a triangle. Looking at the SC here, it says that we're going to extend our previous knowledge of triangles and their properties to include the sum of angles of a triangle, the relationship between the lengths of sides and measures of angles in a triangle, and determine when three lengths form a triangle. In this video specifically, we're going to focus on the relationship between the lengths of sides and measures of angles in a triangle. Let's review a little bit here the triangles that we understand. We have equilateral triangles, isosceles triangles, and scalene triangles. They are named differently based on their sides. You can see here in an equilateral triangle, the length of the sides are all equal. They're all the same, as well as the angle measurements. You can see also, let me make sure you understand, this is a little slash here, and each side has the same slash. That's because they are all the same measurement. And now it is the same with the angle measurement as well, with them all being the same. And then here we have an isosceles triangle. That means you have two side lengths that are the same and one that is different. It's identified with the slash on the two side lengths that are the same, and then the angles that are the same. And then finally the scalene triangle, you can see that it has side lengths that are all three different sides, and it is identified as well. One length has one slash, another side length has two. Actually, I guess I should do that in a different color to identify the fact that they are all different. And it is also true with the angles. Okay, so let's take this knowledge and see what it looks like to use this understanding of the relationship between the lengths of sides and the measures of angles. So here's the angle-side relationship explained. Okay, so what we have is we have triangle ABC that has side lengths of 7 centimeters, 9 centimeters, and 4.5 centimeters. Use a relationship between the sides and angles of a triangle to match each side with its correct length. Okay, so what we have is one side length is a 7 centimeters, one is 9 centimeters, and another is 4.5 centimeters. They're all different. We will also notice that our angle measurements are all different as well. We have a smallest at 30 degrees, a mid-size at 50, and a largest at 100. Okay, well, what we know is that the smallest, or I'm sorry, let's start with the largest. The largest angle measurement will be opposite of the longest side, or we could say the longest side is opposite of the longest, or the largest angle. So, if we identify the largest angle, which is 100 degrees, we know that it is opposite of the longest side, and based on our side lengths of 7, 9, and 4.5, that would be the 9. I'm sorry, that would be AC, would be the 9. So the length of AC is 9 centimeters. Okay, now let's look at the shortest length. The shortest length is 4.5 centimeters, and it is going to be opposite of the smallest angle. That would be the 30. So it is opposite of AB. So AB is going to be 4.5 centimeters. And then finally we have the mid-size side length of 7 centimeters. So we have a mid-size angle degree of 50 degrees, and it is opposite of the BC in this example. So that would be the 7. So BC is 7 centimeters. Again, what we need to understand is that the longest side is opposite of the largest angle. The shortest side is opposite of the smallest angle. And the mid-size side is opposite of the mid-size angle. Okay, let's look at a few examples where we apply this understanding. This says that triangle DEF has side lengths of 8 centimeters, 10 centimeters, and 9 centimeters. Use the relationship between the sides and angles of triangles to match each side with its correct length. Okay, so we're given three lengths. We're given a smallest, we're given a largest, and we're given a mid-size. Same is true with the angles. So let's start with DE. Down here it's asking about the length of DE. So if we're trying to figure out what DE is, DE is opposite of the 50 degrees, and 50 degrees is the smallest, and our smallest is going to be the 8, so that is going to be 8 centimeters. Alright, now it wants to know about, or let's look at EF. Here I will highlight EF, and it is opposite of the 71 degrees. 71 degrees is our largest degree angle, so it's going to be opposite of the longest side, which was 10. So that would be a 10. And then finally, of course, what's left over, but let's go ahead and look at the DF. And if I were to highlight the DF, that would be here, and it is opposite of the 59 degrees. 59 degrees was the mid-size angle, so it's going to be the mid-size length of the sides as well, and the mid-size was 9, so that's why the DF would be 9 degrees. Okay, let's look at an additional example here. It's a little bit different in that it gives us the it wants us to determine which angle measure belongs where. So we have triangle KLM has angle measures of 37, 90, and 53. Again, use a relationship between the sides and angles of a triangle to match each angle with its correct measure. So again, we have a smallest angle, we have a largest angle, and we have a mid-size angle. So here, down here, we're starting with angle K. They want to know what is the measurement of angle K. Well, angle K is right here, and you will see that it is opposite of the side length 7.5, which is the smallest side length. So angle K is going to be the smallest angle, which is the 37 degrees. So the measurement of angle K would be 37 degrees. Okay, now it's asking about the measurement of angle L. So we will highlight the measurement of angle L, and it is opposite of KM, which is 12.5. And it is the longest side, so angle L is going to have to be our largest angle. And in our given problem, the largest angle measurement is 90 degrees. So the measurement of angle L is going to be 90 degrees. So that could have been highlighted as a 90-degree angle. Okay, and finally, last is the measurement of angle M, and it is opposite of the 10, and it is the mid-size length, so it's going to be the mid-size angle measurement, which is 53. I mean, I understand you could have done that by process of elimination as well, but it is the 50 degrees. I should add my degree signs here. So that's how you would apply your understanding of relationships to determine which angle is which measurement. Okay, let's look at practice problem 1. This is a pretty challenging application problem. If you want to go and try to solve it, pause the video and try to solve it, and then I will go ahead and work through it here. It says that in a flag, two sides of an isosceles triangle flag are 7 feet and 5 9/10 feet in length. Two angles of the triangle measure 65 degrees. What is the perimeter of the triangle? So ultimately, we're trying to determine the perimeter. So we're going to have to know the side lengths. Now, we're given two side lengths of 7 feet and 5.9 feet, or 5 9/10 feet. And we're also told, very importantly, that this is an isosceles triangle. That means two of our measurements are going to be the same, or two of our side lengths are going to be the same. So we may have two 7 feet lengths, or we may have two 5 9/10 feet length, and we're going to have to determine that. And what we're going to use to determine that is this idea that two angles of the triangle measure 65 degrees. So if we know that we have two 65-degree angles, and we also know that all three angles of a triangle add up to 180, which we learned in a previous video, we know that x plus 65 equals 180. Well, let's combine what we know here. 65 and 65 gives you 130. So now it says x plus 130 equals 180. And when we subtract 130 from 180, we're left with x equals 50. So we know that our third angle measurement is 50 degrees, which is smaller. The 50 degrees is smaller than the 65. Therefore, the smallest angle would have to go with the smallest measurement of 5.9 feet. So then we know that the 65 degree will be opposite of the 7 feet. So what we understand then now is that we have two 7-foot side lengths, and we have a 5.9. Again, just to show you what I mean, the two 65-degree angles were opposite of the largest length of the side, which was 7, and then the 50 went with was opposite of the smallest length. So now we just need to add 7 plus 5.9, and if we combine these two, 7 plus 7 is 14, plus 5.9. I'll work that out for you here. 14 plus 5 and 9/10. We add that up, we get 19 and 9/10. So that was a pretty involved problem. We had to use your understanding of the relationships of angles and sides to determine that unknown length and then add it up to find the perimeter. Okay, let's look at practice problem number 2. Two sides of a triangle that is part of a garden design are 8 feet and 9 feet in length. The total distance around the triangle is 29 feet. Two angles of the triangle measure 50 degrees and 85 degrees. What is the measure of the angle opposite of the 9-foot side? Okay, so what we understand is that we do have two known measurements of 8 feet and 9 feet, but they also tell us the distance around the triangle is 29 feet. So we have three sides of a triangle. One is unknown. The other two are known. One is 8 feet and one is 9 feet. And added up, they all equal 29 feet according to this example. So we just need to do the math on this equation here to determine the length of the missing side. If we will combine the 8 and the 9, we'll get 17. So now it says x plus 17 equals 29. And then to finish out this equation, we need to subtract 17 from both sides. Subtract the two side lengths that we know to figure out the missing one, and x equals 12. 12 feet to be exact. Okay, so we could draw our triangle if we wanted to, or we understand that we have three different side lengths of this triangle. We have 8 feet, and we have 9 feet, and we have a 12-foot side length. Okay, so how do we figure out which or what is the measure of the angle opposite of the 9-foot? Well, we know already that the 9-foot is the mid-size side length of this triangle, so we're looking for the mid-size angle measurement of this triangle, and we're given a 50-degree angle and an 85-degree angle. So what we need to do is figure out what is the missing angle. Well, I'm going to combine the 85 degrees plus the 50 degrees. So I can figure out what the two known angles equal together. So that's 135 degrees. Well, what's left then is what we need to get to 180. So if we will simply subtract 135 from 180, and when we do subtract that, we end up with 45 degrees. So we have a 50-degree angle, an 85-degree angle, and a 45-degree angle. Well, you can see that the 50-degree angle is the mid-size angle, so that goes with the mid-size side length, 50 degrees. So the answer is the angle that is opposite of the 9 foot would be the 50-degree angle. Okay, that is a look at applying our understanding of the relationship between the lengths of sides and measures of angles in a triangle.